Hello, everyone. So I have prepared your practice midterm number 2. And again, every recording that I do is to help you do better and perform better on either a quiz or a midterm. I do similar problems that you're going to be expecting on a quiz or on a midterm. I will not do all of the problems for you, but I will give you a taste. And the rest is up to you for you to study and to do your homework. And that will be this is just an aid for you as an additional way to study and to prepare for your midterm. So in this case, practice midterm 2. This covers sections 10.1 through 10.5. We actually skipped 10.4 as you noticed. So practice midterm 2 consists of chapter 10 only. So I'm going to go over some questions. How many proper subsets are there for the given set? 1, 2, 3, 4, 5, 6. So we notice that we have 6 elements in the set. And this is a formula that you need to know for proper subsets. So this P represents the elements in the set. So to find how many there are, you do 2 to the 6th minus 1 because there's 6 elements. 2 to the 6th, it's 2 times 2 times 2, 64. If you don't know that, you can use your calculator. You can go ahead and do 2 raised to the 6 gives you 64 and then subtract a 1. So that means there's a total of 63 proper subsets for this particular set. Okay. So that's the formula that you have to know. Now, what if I give you N and R? You should be familiar with these when we're doing a combination and a permutation. This is a permutation. This is a permutation formula that you have to know. And this is the combination formula. And you should know how to evaluate factorials. So the first one, you're plugging it in into 13 factorial over 13 minus 6 factorial. Remember, I'm substituting 13 and 6 in place of N and in place of R. So 13 factorial looks like 13 times 12 times 11 times 10 times 9 times 8 times 7 times ... all over, well, 13 minus 6 is 7 factorial. Remember that I'm going to be able to cancel this 7 factorial with this 7 factorial. And you should be familiarized with that because you did your quiz. So this is 13 times, you're only left with 13 times 12 times 11 times 10 times 9 times 8. Again, using your calculator, you do 13 times 12 times 11 times 10 times 9 times 8. And you get 1, 2, 3, 5, 5, 20. You get 1,235,520. So if you plug it in versus a combination, that's 13 factorial over R, which is 6 factorial, 13 minus 6 factorial. Again, you get 13 factorial, you get a 6 factorial and a 7 factorial. So it's going to act the same. It's going to be now 13, one second. And I'll get rid of this. We're going to do 13 factorial over, well, we are again, 13 factorial is 13 times 12 times 11 times 10 times 9 times 8 times 7 factorial. And then there's a 6 factorial downstairs and a 7 factorial. You're going to cancel all of the 7 factorials over here. And then you're going to have 13 times 12 times 11 times 10 times 9 times 8 all over 6 factorial. So on your calculator, we already know what 13 times 12 times 11 times 10 times 9 times 8 is. It was 1,235,520. Divide that by 6 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. So we're going to go ahead and take this quantity. So 6 factorial, 6 times 5 times 4 times 3 times 2 times 1 is 720. So 1,235,520. Divide that by 720. So I have 5,520. Divide that by 720, and that would be 1,716. And that's the combination. Notice the 2 different numbers, a permutation and a combination. So this is the answer for each. Okay. When you plugged it into a permutation, it gave you a way much larger number versus a combination. Okay. That's question 2. Question 2 was substitution only. Evaluate 11C3. Well, what does this C mean? This means a combination. 11 combination with 3. Remember that N is always the bigger number and R is always the smaller number. So you use the combination formula because they want you to do combination. So it's N factorial over R factorial, N minus R factorial. You already have your N and your R. So all you have to do is plug it in, 11 factorial over 3 factorial, 11 minus 3 factorial, and we keep playing the same game. 11 factorial is 11 times 10 times 9 times 8 times ... all over 3 factorial, and then 11 minus 3 is 8 factorial. So the 8 factorial will cancel. You'll be left with 11 times 10 times 9 in the top over 3 factorial, which is 3 times 2 times 1. Here I get 6 on the bottom, and then on the top I get 900, and so 11 times 10 times 9, 990. That's why you have your calculator, nice and useful. 990 divided by 6, you get 165. Those are the combinations when you do a combination of 11, taking 3 things at a time. Okay. Now this is important. What does it mean to have distinguishable arrangement? That one's a different formula. Distinguishable should be the keyword. So first you need to count how many letters does the word have. So tomorrow has 1, 2, 3, 4, 5, 7, 8 letters. 8 factorial. Now you're selecting distinguishable arrangement. So O, how many O's do you see? You see 1, 2, 3 O's. So that'd be 3 factorial down here. So you see the repeated letters. So another repeated letter you see is R. You have R, there's 2 of them, so that's 2 factorial. Is there another repeated letter? It doesn't seem like yet. So the only repeated words, the most that you see is O and 2 R's. So then all you do is simplify 8 factorial. Again, it's 8 times 7 times 6 times 5 times 4 times 3 factorial all over 3 factorial, 2 factorial. You have a 3 factorial on the top and a 3 factorial on the bottom. And you're left with 8 times 7 times 6 times 5 times 4 all over 2. So then you divide it out, you multiply 8 times 7 times 6 times 5 times 4, right? That gives you a total of 6,720, and then take that number and divide it by 2 because there's a 2 downstairs, or 2 factorial. 2 factorial is 2 times 1, which is just 2. You're left with 3,360. This is how many distinguishable arrangements you have for this particular word. Again, this is what you're going to be doing when it says distinguishable arrangements. Okay. So we have number 5, in a race of 9 cars that have entered with no ties, how many ways can you, or can the first 3 come in? So you have first place, you have second place, third place. So first, second, and third. Well, we started with 9 cars, and then 8 cars, and then 7 cars. So it's 9 times 8 times 7. If it's in how many ways is the first 4 finishers come in, that'd be 9 times 8 times 7 times 6, right? We started with 9 cars and then start decreasing. So you actually multiply 9 times 8 times 7. So you're looking for 9 times 8 times 7, 504 ways. And this is your answer. Okay. So if you toss 4 coins, how many ways can you obtain at least 2 tails? Well, on that one, you want to maybe create a tree diagram. So first is heads and tails, 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 heads and tails. It becomes a little bit complicated afterward because you have to have 2 choices for each. And then last. So you're going to end up with 2 to the 4th or 16 choices. You're going to have a head, 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 head. This one. You can end up with head, 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 tail. And then you can end up with head, 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 tail, head. So you're following the diagram, or head, head, tail, or head, 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 head. So we want at least 2 tails. So the next one would be head, 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 tail, head, which we already have. We did it twice. Head, tail, tail, right here. And then we have head, tail, head, 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 tail, head, tail, head, tail, tail, head. So you look at the choices, there's going to be a total of 16 choices. We do, and you want at least 2 tails. So you're going to be counting how many of the tails will you have. Okay. So you want to make sure you do that. You're going to go through all of them. Okay, so that is your job. You want to make sure you do and you create your own different ones of how many possibilities of 4 of different coins you'll have. So then you are able to count how many at least can you end up with, how many tails, okay? So that's what you want to do for that, okay? So you're going to be counting them. So in a multiple choice test consists of 10 questions with each having 3 possible answers. How many ways can you, how many ways in total can you select? Well, or how many can you mark? Well, you have 3 possible answers, 10 questions. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this one has 3, this one has 3, this one has 3, this one has 3. They all have 3 choices. So this means it's 3 raised to the 10th power. Okay, that's how many ways you can mark your answer. And again, you're using your calculator here. You have 3 raised to the 10th. That looks like 559,049 ways. This is when you have a multiple choice test consisting of 10 questions with each having 3 possible answers. So it'd be 3 at a 10th, 3 raised to the 10th. Okay. Now the next one is you want to find the sum, or how many sum of the dice lies between, 4 and 10. So you want to use a product table. You should be familiarized with this product table. You should have seen this before. So the product table are the choices 1, 2, 3, 4, 5, 6 on your die. Oops. And then vertically are your other 6 choices that you have 1, 2, 3, 4, 5, and 6. And remember, they are coordinates, so you can have 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6. You should have this already written down in your notes somewhere. So then you don't want to waste time and do that. 3, 1, 4, 1, 5, 1, 6, 1. So you want to find between 4 and 10. You are excluding 4 and you are excluding 10. So 2, 2, and you're looking for the sum of them. The number that lies between, this is 5, 2, 6, 2. I'm going to go ahead and complete it. 6, 3, 6, 4, 6, 5, 6, 6, 5, 6, 4, 6, 3, 6, 2, 6, 2, 5, 3, 5, 4, 5, 5, 5. So this one has 36 possibilities, but you want to find the sum between the numbers 4 and 10, excluding those numbers. And this is 5, 4, 5, 3, 4, 3, 3, 3, 2, 3, 2, 4. I'm almost done here. 3, 4, and then 4, 4. Okay, so you are excluding 4 and 10, the sum of them. So 1 plus 1 is 2. That doesn't count. 1 plus 2, that's 3. That doesn't count. And excluding 4 and 10, that doesn't count because this gives you 4. This gives you something less than 4, so that not that one. Between 4 and 10. So that'd be 5, 6, 7, 8, 9. The sum of them will give you either 5, 6, 7, 8, or 9. So you're excluding, sorry about that. You are excluding 4, you are excluding 10. So you cross these out. You're crossing these out because you're not allowed to be either 4 or 10. Or in between, you only have to be in between. So 1, 4, that's 5, 6, 7. This is 5, that's good. This is 6, that's good. This is 9, that's good. But this one, 4 and 6, that's 10. We have to cross that one out. Is there another one? I don't think so. So in total, we want to find how many? 1, 2, 3, 4, 5, 6, 7. Be careful, 3, 1 gives you 4. We can't pick that one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 24. So there's 24 different outcomes for this one. So you are excluding 4 and you are excluding 10. So 24 outcomes. All right, number 9, find the combination of 11 things taken 5 at a time. So again, it's 11 combination with 5. The combination formula is n factorial over r factorial, n minus r factorial, where n is the bigger number and r is 5. This is 11 factorial over 5 factorial, 11 minus 5 factorial. You're left with 11 factorial over 5 factorial, 6 factorial. 11 factorial is 11 times 10 times 9 times 8 times 7 times 6 times 6 factorial, all over 5 factorial, 6 factorial. Your 6 factorials will cancel. You should be familiar with this already. This gives you 11 times 10 times 9 times 8 times 7, all over 5 factorial, but 5 factorial is 5 times 4 times, so if I do 5 factorial, 5 times 4 times 3 times 2 times 1, that's 120. So I'm going to go ahead and do 11 times 10 times 9 times 8 times 7. That gives me 55,440 divided by 120, which was my 5 factorial. And that gives me 462 choices. So that tells me that is a combination of 11 things taken 5 at a time. Okay. Now you want to construct a tree diagram for 3 fair coins. So the first is either heads or tails. Next one is either heads or tails, heads or tails. This one is heads or tails, heads or tails, heads or tails, heads or tails. So then all you have to do is count. You have head, head, head. You have head, head, tail. So you're going this way, and then you have, or this way, this way, this way. And then you have head, tail, head, and then you have head, tail, tail, and then you have tail, head, head, tail, head, tail, 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 head, or tail, tail, tail. Okay, so this is your tree diagram for 3 coins. So first coin, second coin, 3 coins. Okay, so here you have 8 outcomes. So again, I'm just reviewing right now something that you should have seen already in the past. So this should not be new to you. In how many ways can a principal give 4 different raises to 4 of her 20 employees? So this is a permutation where n is 20 and your R, you're permuting 4 different employees. So it's 20 permutes 4. Remember, permutation has a formula that looks like n factorial over n minus r factorial. All you have to do is plug and chug. You have 20 factorial over 16 factorial. How did I get 16? Well, 20 minus 4 gives me that 16. So maybe you need that extra step here. So you get 20 factorial over 16 factorial. Well, you already know that 20 factorial is so 20 factorial over 16 factorial is 20 times 19 times 18 times 17 times 16 factorial all over 16 factorial. The 16 factorials will cancel, and you're going to be left with 20 times 19 times 18 times 17. So let's go ahead and multiply that out using your calculator again. So make sure you have your calculator in handy when you're doing your tests. So you have 20 times 19 times 18 times 17. That gives you 80, 116,280. That's how much you get. Okay, that's how many ways she can give out the prizes or the raises for her employees. It's a permutation. So determine the number of arrangements or permutations possible of 7 things taken 4 at a time. So that one is already telling you what to do. You want to permute. N is equal to 7, R is equal to 4. You use the formula n factorial, n minus r factorial. You get 7 factorial over 7 minus 4 factorial. 7 factorial over 3 factorial. So here nothing cancels, so you can go ahead and use your calculator, if you will. So 7 factorial is 7 times 6 times 5 times 4 times 3 factorial, all over 3 factorial. So then you have 7 times 6 times 5 times 4. 7 times 6 times 5 times 4. 840 ways. And that's your solution for the permutations of 7 things. Excuse me, taken 4 things at a time. Okay. Alrighty. So we are over here. Again, this is evaluating. This should be easy for you. So it's 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 factorial. And then all over 8 factorial. These will cancel. So you're left with 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9, because the 8 factorial is canceled. And then your calculator handy dandy will do that magic for you. But make sure you do this slowly. So when you're inputting it on your calculator, 16 times 15 times 13 times, don't miss a number, okay? A lot of people like to skip. So 16, 15, 14, 13, 12, 11, 10, 9. Make sure you're going in reverse order. So 13 times 12 times 11 times 10 times 9. It's a big number. So it's 518,918. 518,918,400. That's what you get. Okay. You don't have to put in commas in your solutions when you're typing your answer. You don't have to use, you just put it in there. Okay. And the last one, I believe, well, there's a few more. There's 2 more. So what are the differences between a combination and a permutation? Well, that one you should know. You can find those in your lecture notes. Okay, so when you're dealing with a permutation versus a combination, one of the differences, so when you hear the word permutation, it's more of like arrangements. When you hear the word arrangement, that should be a hint that you're doing a permutation instead. The sequence is important. It doesn't really matter who's first or who's last. And a combination is actually a selection. You're selecting things from a location or from something. You are doing a selection. You're not doing an arrangement. Okay. So you want to make sure you notice the differences. Also, another thing, combination order doesn't matter. Here it does. Order is important here. So both of these are without repetition. And then also you can look at your notes. So here you have to notice the 2 differences between them. But most importantly, the keywords, when you hear the word arrangements versus selection, that's something that you want to definitely look at. And then here, I'm also going to say, go back to the lecture notes. There's also examples there on chapter 10. Okay. I think it's section 10.3, I believe. All right, number 15, when 4 coins are flipped, you have 2 to the 4th outcomes, right? You have 16 outcomes. How many outcomes will you have if you flip 6 coins? So that one is, again, when you have a coin, there's 2 options. Which ones, heads or tails? But you have now 6 coins, so it's 2 to the 6 options. So that is a total of 64 outcomes. So your solution would be 64 different outcomes if you flip 6 coins, a fair coin, right? Because a fair coin has only 2 possibilities, either heads or tails. Okay. So this again is a minor review, definitely something as extra practice. I would not just do this review and then attempt your midterm. Do not do that. Please make sure to look at your notes, do your homework assignments, and then as a complement, look at this practice review that will help you for your second midterm. All right, guys, thank you so much. I hope this was useful, and I will see you in the next recording.